When we start to look at solving trig equations, we need to be able to distinguish between what we call linear form and quadratic form. A linear form of an equation is an equation that contains our trig functions, but the powers of those trig functions are no higher than 1. Quadratic form means that we have at least one trig function either raised to the power of 2, or we may have two trigonometric functions that are being multiplied together. If the equation is in linear form and only one trig function is present, then we will use linear equation methods to get the function on one side and a number on the other side. Essentially, our whole goal for solving trig equations is to get the function on one side and a number on the other side. Sometimes, though, we have the quadratic form, and there are several different methods that we might have to employ in order to solve a trig equation in quadratic form. Very similar to the methods that we use in algebra to solve quadratic equations. We have what we call the square root method. So if we have only one trig function and it is being squared, and we have no linear term, then we can take the square root of both sides. And if you do that method, we want to make sure that we don't forget the plus and minus. If we have a trig function squared and there's another term that contains a trig function that is not squared, then we can try to rearrange the equation just like we would have done in algebra, get everything on one side, 0 on the other, and then try to factor. And then just like in algebra, once again, if you cannot factor something that's in quadratic form, then we have our quadratic formula. So if we were using the quadratic formula, we would get the trig function on one side equals, and then that old familiar quadratic formula on the other side. If there's more than one trig function present, say we have sine and cosine within the same equation, the first thing that I would recommend is that we get everything on one side, 0 on the other, and try to factor. If factoring doesn't work, to isolate the trig functions in each of their own linear equations, then we might have to start to use identities to rewrite the equation so that we can get it in terms of one single trig function. Sometimes we might have to square both sides of the equation, in which case we must make sure that we actually check our solutions in the original equation to see if it works. Once we have isolated the trig function to be on one side and we get a number on the other, our goal is to determine what angle would actually make the statement true. So when we solve, we're solving for angles. If we're asked to solve within an interval from 0 to 360 degrees, we're given that interval, we will be looking for angles in degrees on our unit circle. If we're asked to find angles from 0 to 2 pi, then we assume that we are working in radians. When we are looking for angles that satisfy the given statement, we make sure that we use reference angles to find all angles that have that trig ratio. So we're not looking in just one quadrant, we will be looking in two quadrants where the trig function is positive, since all trig functions are positive in two quadrants. And if we're given a negative value, then we're looking for both quadrants, the angles in both quadrants, where that trig function would be negative. So we're going to use our reference angles that we talked back in a previous section to determine all the angles within the unit circle that have that particular trig ratio. If we are asked to find all possible solutions, that means we're looking for all coterminal solutions to the angles that we find on the unit circle, then we are going to add 360 in, which means all multiples of 360, integer multiples, or integer multiples of 2 pi, depending upon if we're working in degrees or radians. Sometimes we will be able to write this more concisely by just adding 180 degrees times n, so multiples of 180 or multiples of pi. For tangent and cotangent, we will always be able to write it as multiples of 180. So when we are adding to find all possible coterminal solutions, tangent and cotangent will always be able to be written more concisely.